This is a man who you probably don't recognize, but I'm willing to bet the CS majors watching this have heard of his work. As a graduate student at MIT, he would invent Huffman coding while working on an assignment for an information theory class taught by Professor Robert Fano. Professor Fano gave each of his students a choice. They could write one exam or one term paper in his class. David chose to work on the term paper because we all know how stressful final exams are, even if we don't go to MIT. Choosing the term paper meant Huffman had to discover the least wasteful way to represent a collection of values with binary codes. And in doing so, he would invent a new lossless compression algorithm that was guaranteed to provide an optimal solution, and he named it after himself. Take the word hello. We can represent each letter with the ASCII value, like this, and then convert each decimal value to an 8-bit binary value. This is how a computer will store the word for us to use later. But you can see it isn't a very efficient way of doing things. We've had to convert a 5-letter word to a 40-digit binary representation. There are a ton of wasted bits here. And using the algorithm David Huffman proposed in his term paper, we can replace those 40 digits with only 10, and I'll show you how later on. Huffman coding was largely based on shannon-fano coding, which used binary trees to generate prefix-free codes for each character. The beauty of using binary trees is that there is no ambiguity in the coding. Prefix-free means no character's code was a prefix of another character's code. Shannon-fano's flaw is that it is not guaranteed to generate the most optimal solution for a set of characters, but Huffman was able to alter the algorithm to ensure an optimal solution was always reached. Huffman's change was to make the tree start at the least common letters and work up to the most recurring characters. We start by counting the number of occurrences of each letter and sorting them by how often they occur. We'll grab the two least recurring characters and put them in a binary tree. We then sum their number of occurrences together and place them back in the list based on that combined number of occurrences. Next, we take the two least characters from the list and continue the same process until we get a tree looking like this. From this tree, we can generate the correct unique codes for each letter by parsing the tree. Every time we take the left path, we add a 0 to the code, and every time we take the right path, we add a 1. The correct code for the letter H is 01 because it goes left and then right. We can build a table containing all characters and their codes to be used in the future. This is what our table for the word hello would look like. When we want to decode the message, we can again use the tree by starting at the top and traversing left or right until we reach a leaf node. Huffman's algorithm is a perfect example of a greedy algorithm because it makes the best choice at its given moment. Letters with the lowest number of occurrences should have longer codes than letters that occur often. It makes sense to start with the fewest reoccurring characters at the bottom of the tree and work our way up to the top reoccurring characters, which ensures that commonly appearing letters have shorter codes than characters with fewer occurrences. In short, the algorithm makes the greediest choice based on the frequency of characters, which leads to an optimal solution. The optimal solution for this video is one where you enjoyed it so much you decided to subscribe for more. Thanks for watching.